So we've talked about how using degrees to measure trig functions like sine is kind of cool, except that we don't know quite how much to squeeze in or pull out of the graph of sine x because we don't really have an effective conversion unit between degrees and normal numbers. And it would be kind of cool if we could find some sort of way of graphing the sine graph where we had kind of apples and apples in the X and Y axes. And so let's take a look at a problem where we can do exactly that. So I'm going to be over here in GeoGebra. And what you see I have here is I have a semicircle and I've got a point on the semicircle and I'm going to measure two different distances. I'm going to measure the length of the arc down to this corner here, and I'm going to measure the height over the horizontal diameter there. So that's going to be my y value. So you can see that my x and y values change as I move this point around. I can even move this point over here to the far side, so y is getting small while x is continuing to grow. And so that's kind of a cool thing. So why don't I take a point here on this graph and we can see how for different values of x and y, this traces out a curve here. All right. And if I turn on the trace on this point, we'll be able to see better what that curve looks like. All right, so going through all kinds of different points up to the top of the triangle. Now the height hits 1 at that point, and now it starts to drop again. And it comes all the way over here. And let me fill in the rest of that over there and over there. All right, so does this graph look familiar to you at all? Well, it might look a lot to you like the graph of half of the sine wave. And that's well intentioned. We can show that it is, and I'll give you some indication of that in just a moment. But the idea here is think about what our x and y measurements are measuring. So this is a unit circle, a circle with radius 1, and I'm measuring the length of this arc. So this is a distance in terms of just plain measurement units, and y is also a distance. So my x and y values are both numbers, and it gave me what is effectively a sine wave at this point. So that's really exciting. So that is kind of what we were looking for. It's a natural curve of the sine wave that doesn't involve this artificial number of 360 degrees in a circle. So first of all, let me give us a little bit of an indication that this does represent a sine wave. Let me draw that in there. So we've got a right triangle here. As I said, this was a unit circle. And so if I think about this angle right here, the sine of this angle is y over 1. Y over 1, because sine is opposite over hypotenuse. So that's y, and the radius of the circle is 1. So y does represent the sine of this angle. So this is measuring sine, except that my x units are not the degrees of this angle, but the length of this arc. And so what we're going to do now is we're going to say, well, we could define the measurement of this angle as the length of this arc for a unit circle. And we could say that this angle is equal to 0.98. We're going to need a name for this degree, for this measurement. So we're going to call this radians. So 0.98 radians is equal to 56.02 degrees approximately. And both of these angles we can see have a sine of 0.83. Okay, so let's do a little bit more looking around at this. So I can see, first thing that I can see is all the way at the end here, I can get a really tight conversion unit here because I can see that 180 degrees is equal to exactly pi radians. All right, that is the circumference of a semicircle with unit one, and that's 180 degrees. So that's going to give me the ability to convert effortlessly between degrees and radians if I want to. And another cool thing I can do is I can work here to where this x is exactly 1. Let's see if I can find that spot. There we go. So this is a little bit of an estimate, but this is an angle of 1 radian, and it represents 57.38 degrees, more or less, somewhere between 57 and 57 and a half. It's not exactly right, um, but that is our conversion that we can use between degrees, which we're used to. Degrees are nice. I'm not totally, down on degrees. The nice thing about degrees is that 360 is a really it's a number that can be evenly divided into a bunch of units, and it has a whole bunch of factors. So 45 goes evenly into 360, 30 goes evenly into 360, 10 goes evenly into 360. We can break a circle into 5 equal pieces, or 8 equal pieces, or 15 equal pieces, and each one is going to represent a whole number of degrees. So there are a lot of nice things about 360. The only bad thing about it is that it's a number that humans pulled out of their hat, and so it's slightly unnatural in that sense, in a way that pi radians is not. So that's kind of uh, the motivation for creating radians as an angle measurement, and hopefully you have a more mature sense of how it all plays together now.